Hey everybody, this is Mr. Kane, and this is a video that's going along with the Beam Deflection Lab Part 2, which is taking the data that you calculated on the lab Google Doc and converting it into this Google Sheets model. So this is going to be a series of videos that's going to help you build this model. And this first video is simply showing you how it's set up and giving you a little bit of instruction to get started. So the first thing you're going to want to do, obviously, is open a Google sheet and name it up here in this where you name your file. And we want to call it moment of inertia, beam deflection testing, and then you can just basically maybe put your last name right here like that. The next thing you want to do is come down here with any spreadsheet data that you present as you go into college or in high school or your job. You want to have a title and the name of your company or the school and the name of the project and whatnot. So what I'd like you to do in the upper left here is select size 12 font in bold for this first row here, and we can put in moment of inertia and beam deflection testing. Same size font in bold, engineering honors 2, and then you can go down to a font size 10 to put Kennebunk High School and then the date. The next thing you're going to want to do is we're going to have basically, this is the first part of your lab experiment where you basically calculated the moment of inertia for a 2x4, and you have the span and the distance and your measured deflection based on someone's weight, and we calculated the modulus of elasticity. So the first thing you're going to want to do is just basically come in here to row 6, and in bold, size 12, you can put testing phase 1. Person of a known weight stands on the beam in the horizontal orientation. In other words, we're taking the 2x4 and we're laying it down flat, not up on edge. We're going to solve for the modulus of elasticity. So you can write that in, and then what you can do here to format this up is you can click on here and drag over to here where we've highlighted all those cells. And then you can just go up to this paint fill color and select whatever color you want. I've selected a light green, and that will color those in and make it look nicer. Then what you want to do is you're going to have 2 rows, and what you can do for this row, where you can see I've got these words and they are wrapping around this cell. And what you can do there is you can select these cells just like that, and you can go up to format, and then you can select a few things. You can do text wrapping, okay, and we can do wrap like that. And what that's going to do is when you type in here, you can see here as I drag this in, it's actually going to wrap the text. So you'll be able to, it'll immediately format to how wide the cell is and fit those in. The other thing you might want to do is, because we want this a little taller than our other rows, is grab this bottom part of the row. You can see the arrow changes to a double-sided arrow, and then just drag it down like that, and that'll make that row bigger. That's a technique in building these tables out to format them nicely. So you can see here you want to fill this in with size 10 bold, and you just want to copy my heading titles here for each column. The first one is the beam width, and remember, a 2x4, the actual dimensions, it's actually 3.5 inches wide by 1.5 inches thick. And right here, we're going to cover this in the next video, but you can just leave this cell blank. But you want to put in moment of inertia and the units that it's in. It's in inches to the 4th power. And then the span, or L, that's the variable L, moment of inertia is I. And then the preload distance, that's the distance on the lab that you measured from the middle of the 2x4 down to the ground. the post-load distance, in other words, after someone steps on the middle of the 2x4, how far did it bend down? What is the new distance from the middle of the board to the floor? You can see here this deflected by 1.3 inches. And you can see here I'm calculating the max beam deflection. And again, just you'll see that the cells that are in yellow, those are just inputs by you. The ones that are in green are actual calculations. If you look up here, you'll see that I've calculated the moment of inertia based on the equation in the lab. And you'll also see here that I've calculated because it's in green, I've gone up and colored that green to let the user know that I'm calculating that. And you can see here, I went up and these cells that I had input for, I colored those yellow just to let the user know those are straight inputs, and the green are going to be the ones that you're going to actually put in formulas and calculate. After you put in MD or max beam deflection, and then F is the weight or load, and that would have been the person. And then E is the modulus of elasticity in PSI units, and it's calculated here as well. And you can see the calculation, which again comes from the worksheet. A couple of things here I'm already seeing on mine. I've got a little typo here with of, should be or. And you can see here load distance is between bottom of beam and the floor. It actually was from the middle, so I can change that. Okay, and also I could take this and copy it, Control C, and click here and go Control V and paste it. And so what you're going to want to do is format this first table, and you can leave these green blank. We'll go over that later, okay? Unless I'll click on them right now, and you can see the formulas up here. If you'd like to try to put those in, that's great. You just need to start it with an equal sign and then put the cell in that you want in the mathematical equations. And then there's this one as well. But basically what you could do is you could actually take this whole thing and do a Control C, copy on that, and you could click right in here. Yours will be blank, but you could do a Control V. It'll paste all this and at least get you the general formatting that then you can then change. But this one you're going to call testing phase 2. This is phase 1. This is phase 2, which is person 2 of unknown weight stands on the beam in the horizontal orientation, and we use the calculated modulus of elasticity for that board to solve for the person 2's weight. So in this first one, we know the weight, and we're calculating the modulus of elasticity. This one, we have the modulus of elasticity for that particular board, and we're going to calculate the weight of the person, okay? And then this third one is phase 3 of the lab, and assuming person 2 stands on the beam in the vertical orientation, so we stand the board up so it's taller now, it's going to be in a much stronger orientation. Now we can calculate the beam deflection, and you can already see that it's much, much less because the moment of inertia is higher, because moment of inertia from your videos, you realize is a function of the orientation, the height and width, as related to the direction of the load applied to that member, that 2x4. So you could accomplish these 3 tables right here in terms of formatting them just with their names and their column headings. And you could also enter in what's ever in yellow. And then the last thing you want to do is add notes. Every good table always has some notes to explain calculations and assumptions. So these are the notes. You want to put a heading here for notes and number them 1 through 4. And you can just put what I put right here. Moment of inertia calculation, defining your terms, the max beam deflection calculation with its terms, the modulus of elasticity. All those terms can be found up in here. And then just a general note on the modulus of elasticity, which is a material-based property and stays the same regardless of orientation. So the modulus of elasticity is not affected by the orientation, but the moment of inertia is. So this is your first part of the Google Sheets lab exercise that you're going to want to generate, and then we'll go on to the next part where we'll actually show you how to calculate these, and then we'll go on to create a graph of the relationship between moment of inertia and how much something deflects. And we'll create a table to do that and then graph it up. Okay? Any questions? You can just shoot me an email and I'll be happy to get back to you. Good luck.